A field density test, FDT, also known as the compaction test, is a process used in construction and geotechnical engineering to determine the density of soil at a construction site. It helps to ensure that the soil or material being used for construction meets the specified compaction requirements. Proper soil compaction is essential for providing a stable foundation and reducing settlement risks. Common methods of field density testing. Sand replacement method. A hole is dug in the ground and the excavated soil is weighed. The hole is then filled with calibrated sand from a sand cone apparatus. By measuring the volume of sand used, the volume of the hole can be determined. Using the weight of the excavated soil, the density is calculated. Core cutter method. A cylindrical metal cutter is driven into the ground to extract a soil sample. The weight and volume of the sample are measured to calculate the density. Nuclear density test. A nuclear density gauge is used to measure the soil's density and moisture content. It works by emitting gamma rays into the ground and measuring the reflection. Water balloon method. A hole is dug and its volume is determined using water displacement with a balloon. Importance of FDT. Ensures the soil is compacted to the required density for structural stability. Helps in controlling settlement and preventing soil erosion. Essential for meeting design specifications in road construction, embankments, foundations, and other infrastructure projects. Key parameters. Dry density indicates the compactness of soil after removing moisture. Moisture content, W, determines the water percentage in the soil. Relative compaction, percent, a comparison between field density and laboratory maximum density. The results are usually compared with laboratory proctor test results to ensure compliance.